there, welcome to day 2 of parallel lines and transversals. We are talking about relationships between lines, planes, and naming angle pairs formed by parallel lines and transversals. This is a continuation of what we did yesterday, except now we're going to go into the application of it. But we are going to start with the definitions and the theorems that we worked on yesterday to review and make sure that everybody gets that. So we're looking at these theorems. This first one says, if lines are parallel, then corresponding angles are blank. Corresponding angles. Corresponding angles in this particular drawing would be this side of the intersection and this side of the intersection. Let me show you what I mean. These lines are parallel. We have a transversal here. So they are on the northwest side of the intersection. That would be corresponding angles, and those are congruent angles. So if we want to show the example, we're going to see angle 1 and angle 9. Those are corresponding angles, and they are congruent. Next one. We're talking about if lines are parallel, then same side interior angles are what? So again, we've got these two parallel lines, same side interior. Well, here's our transversal. We are looking for angles that are interior between the parallel lines and on the same side of that transversal. So I'm looking and I see angle 5 and angle 9 are on the same side of the transversal, and they are between the parallel lines. So same side consecutive interior angles are, those are supplementary. So for an example, we've got angle 5 and angle 9. Okay, next, we have, if lines are parallel, then alternate interior angles. Alternate interior angles are, okay, alternate interior angles, well, are parallel, whoops. Our parallel lines are here. This time I'm going to use this transversal just to change it up a little bit. We need an interior. So interior means in the middle between the parallel lines. And then we have alternate. Alternate means they are on the opposite side of the transversal. Those angles are congruent. So that is angle 7 and angle 12. Next one. Parallel. If we have parallel lines, same side exterior angles. So I am going to look at the exterior angles on this one. Exterior means outside the parallel lines. Same side exterior. Same side, same side. So 4 and 16 are same side exterior angles. Oh, I should highlight this for you. Same side exterior angles. 4 and 16, those would be supplementary. Same side begins with S, supplementary begins with S. That's how I remember that one. Okay. The last one is alternate, if we have parallel lines, alternate exterior angles. Oh boy. Alternate exterior angles. Those are going to be angles in the pink that are on alternate sides of the transversal. So I'm going to erase here, I'm going to erase here, the whole thing. Okay. So again, in the pink, here's our parallel lines. Then we want alternate exterior. So alternate exterior would be 3 and 16, or 4 and 15. Those are alternate exterior. So angles 4 and 15 is an example. And alternate exterior angles are congruent. Okay, so moving on. If we have algebra here, measure of angle 5 equals 2x plus 10, and the measure of angle 7 equals x plus 15, we need to find x. So first of all, I need to find the measure of it. I need to find angle 5. And I found it right here. And I'm going to take this algebra and plug it right in here in the picture. It helps me see what's going on. And then I'm going to find angle 7, which is right here, and plug in that same algebra. Okay, when I'm looking at this picture, I notice that I have these two parallel lines and this transversal. Okay, so if I look at those two angles, I notice that those are corresponding angles. Corresponding angles from your notes up here. Corresponding angles are in the blue. That says they're congruent. So if they are congruent, I'm going to just set them equal to each other. So I'm going to take the 2x plus 10, minus 10, set it equal to x plus 15. Well, now it just becomes an algebra problem. We have to find x. So I'm going to take away, no, I'm going to add 10 to both sides. And that means I have 2x equals x plus 25. And I'm going to take x away from both sides. X equals 25. Now we're looking at another one. We have measure of angle 4 equals 4 times the quantity of y minus 25. And we have the measure of angle 8 is 4y. All right, well, let's find those angles in the drawing. Now, angle 4, that is 4 times the quantity of y minus 25. Angle 8, that is 4y. Okay, now I have to look at these angles and figure out what kind of angles they are. So I notice that here are the parallel lines, and here is the transversal. And where are those two angles? Well, I'm looking at this and I say, okay, they're on the outside. So they're exterior, they're not in between the parallel lines. And I also notice that they are on the same side. Same side. Okay, so same side exterior angles, the pink, are supplementary. So these are supplementary. That means I add them to equal 180. So 4 times the quantity of y minus 25 plus 4y equals 180. Supplementary. All right, and then we just do the math. Okay, so I have to do the distributive property here. You get 4y minus 100 plus 4y equals 180. So now I'm going to combine like terms. That would be simplifying. 8y minus 100 equals 180. I'm going to add 100 to both sides. That's the addition property of equality. So I have 8y equals 280. And y, the division property of equality, y equals 35. All right, next one. We are looking at parallel lines here and this transversal. So now I'm noticing that these angles are on the same side, but they're inside between the parallel lines. So if I look up there and I see same side interior, which is in the green, no, same side interior, which is in the yellow, those are supplementary angles. Same side interior angles are supplementary. Well, if they're interior supplementary, that means that we need to add them together to equal 180. So 7x minus 8 plus 62 equals 180. So now again, we're going to combine like terms. We get 7x minus 54 is 180. 7x, we're going to add 54 to both sides, equals 234. So when you do the math and you divide by 7 on both sides, you end up with x equals 33.428, not. So we round to the nearest tenth, x equals 33.4. Okay, this one is a little tricky. So what we're going to do is we're going to split it down to one step at a time again. Measure of angle 1 is 9x plus 6. Well, 1 is 9x plus 6. So I'm going to put that in here. 9x plus 6. That's this angle right here. Measure of angle 2. Measure of angle 2 is 2 times the quantity of 5x minus 3. 2 times the quantity of 5x minus 3. And I'm going to make that in green, sorry. The measure of angle 3. Measure of angle 3 is 5y plus 14. Angle 3 is 5y plus 14. Well, here's what we're going to do. We're going to find x, and we're going to find y. To find x, here's the plan. We are going to look at angle 1 and where it is compared to angle 2. And they're not on the same transversal, so it's really hard to figure this out. However, I can take this, I can take this angle right here and move it right there. That's the same angle. They were corresponding before. Now they're just moved down, which just slid down. So then I can look at that and say, oh, well, angle 1 and angle 2 look like they're vertical angles. So I'm going to set them equal to each other because if they're vertical angles, they're congruent. So I'm going to take 9x plus 6, and I'm going to equal it to 2 times the quantity of 5 minus 3. And now it's a matter of math. Okay, so let's distribute. We have 10x minus 6, and on this side we still have 9x plus 6. Okay, so now I'm going to take 9x from both sides. So I end up with 6 equals x minus 6. And then I'm going to add 6 to both sides. And I get 0 equals x. Reflexive property, X is 0. Okay. So I'm going to erase this, and then we're going to find Y. In order to figure out what Y is, we now are able to plug 0 in for the quantity of X. And if you look at the drawing now, we have this right here and this right here. Those are corresponding angles. Corresponding angles from up above, you know that corresponding angles are congruent. Okay, so we're going to take 2 times quantity of 5x minus 3 and set that equal to 5y plus 14. And you're going, oh, but McFadden, we've got this x here. Well, remember x is 0. So we are going to plug it in. 5 times 0 minus 3 equals 5y plus 14. And now we have to distribute here. Well, 2 times 5 times 0, that's 0, minus 6, and we get 2 times the negative 3. Nope, that's right. Here's where I made a mistake, guys. We didn't distribute yet. I just did this first. So 0 minus 3. So then it becomes 2 times negative 3 equals 5y plus 14. This is negative 6. I'm going to subtract 14 from this side. So I end up with negative 20 equals 5y. And then I do the division, and I get negative 4 equals y. Last one. I'm going to go quick. All right, so we have to find x. So I'm looking at this picture right now, and I see this angle right here. And I see, oh, okay, well, I know what this is right here. So I'm going to use my vertical angle theorem and put it up here to make my math easier, because those are congruent. Now I have these interior angles, so I can set those up to figure out what x is. So I'm going to take the 5x plus 40, since these are interior, same side interior angles, I'm going to add those two together and set it equal to 180. So again, math, it's just 7x plus 40 equals 180. Take away the 40. 7x equals 140. X equals 20. All right. We will be going over this in class tomorrow, so I know that probably we will go over a couple of these back page ones, just because they're a little tougher. But have a good night, and we will see you with questions tomorrow.